Assalamu alaikum. I welcome you to this new subject, which is flexible AC transmission system. Its subject code being ELE E10T. So in this lecture, I'm not going into the details of this subject. I just introduce you this subject. I'll first uh, tell you about the definition of this FACTS devices or FACTS technology, and based on the definition, I'll slightly introduce you the different contents that we are going to cover in this subject, and definitely the contents or syllabus and the recommended books that are being recommended for this subject. So let us move ahead. So flexible AC transmission system, let us try to introduce a bit about this, and in short it is usually known as FACTS. So it is the AC transmission system that has been incorporated by some power electronic devices and some other static controllers. Usually they are used to enhance the controllability and enhance the power transfer capability. The actual motto of this fact is to increase the power transfer capability. I have actually, you can see, highlighted these two words, that is controllability and power transfer capability. As I have told you that the main motive of the FACTS technology or the FACT devices is to increase the power transfer capability. As you know that the load demand is increasing day by day, and as we have to meet that load demand, the generation as well as the transmission has to increase, or we can say transmission capability has to increase. So to increase the transmission capability, we need to construct more and more transmission lines. But to construct a transmission line is not an easy task because it has a lot of hurdles, or we can say it has a lot of problems associated with it. So what fact technology does, it tries to eliminate the construction of the new transmission line. It tries to enhance the power transfer capability of existing transmission lines. So in that case, the problem of constructing the transmission line may get to somewhat eliminated, or we can say it gets reduced. Sometimes if we have to construct 10 transmission lines by using the fact devices, we may have to construct only 2 or 3. In that way, it is also advantageous. And it has one more advantage, that this power transfer capability has been increased in a controlled manner. So that's also its advantage. So here I have written two equations. One is the real power and another is the reactive power. So real power is usually given by, for a lossless line, it is V1 V2 by X sine of delta, where V1 and V2 are the two terminal voltages of the transmission line, X is the reactance of the line, and delta is the load angle or torque angle, or we can say power angle, that is the angle between V1 and V2. So it is like this. So I can write this real power as a function of these three quantities, that is voltage V1 or V2 combined as a voltage, this reactance X, and this delta power angle. Similarly, Q is equal to V1 V2 by X cos of delta minus V2 square by X. You know the terminology, or we can say nomenclature of different parameters. So again, this is the function of this V, X, and delta. Usually, as I have told you in the previous classes, in the power system classes, that this P is usually a function of delta. In general, it's a function of all the three parameters, but as we change voltage X and delta, it is more, we can say, the change of P with respect to delta is more as compared to V or X. So it shows more change with respect to delta as compared to this. So, but it is usually, even if it changes uh, very less with respect to voltage, or we can say with respect to X, but it is still changing, showing some change with respect to voltage and X. Similarly, Q is a function of all the three parameters, but usually its more change will be, or we can say it is more or less a good function of the voltage itself. So usually you can see why I am using these two equations or why I introduced you these two equations in the introductory lecture. It is because mainly we want that the power transfer capability or capacity of the transmission existing transmission line has to increase, but by doing so increase the power transfer capability or changing this P, this Q also automatically change. So we can say that this fact technology in general is the compensation or we can compensation of the real and reactive power. So based on these three parameters, that's voltage, X and delta, we have different power electronic converters or this controllers. So we'll be going to discuss these one by one. That is the controllers which are based on voltage, which are based on reactance, or which are based on delta. So they can change this P automatically. This will also change, and there are some other controllers where there is an independent control of this real power and reactive power. If we change this real power, there will be no change in reactive power, and if we change reactive power, there will be no change in real power. But in most of the power electronic converters, you will see that they are changing dependently on each other. Because if you change Q, P will automatically change. If you change P, Q will automatically change. We'll see that how this change will take place. So basically, you can say that FACTS controls is nothing but the controlled real and reactive power compensation, and based on these real and reactive power compensation we have different types of the controllers. So before going into the explanation or you can say uh, discussion of these facts controllers, as I have told you in the beginning of this class, that in this case I'm not going into the details of these controllers. We'll just introduce you, or we can say I will just tell you which type of controllers we are going to discuss, and that will be uh, in the contents of this. So we'll first start with the introduction, and then we will have shunt compensation. In shunt compensation we have two types of compensators. One is static power compensator, which is usually based on thyristor. It is a semi-controlled compensator or semi-controlled power electronic device. And we have a STATCOM, static synchronous compensator. This is a fully controlled compensator. It is usually using the MOSFETs. We'll also discuss why this synchronous come over here and what does this static mean. Series compensation, we have TCSC, thyristor controlled series capacitor. So here, as the name suggests, we have a thyristor, and this is also a semi-controlled converter. Similarly, SSSC or triple SC, static series synchronous compensator. This is shunt, this is series. So here also we'll discuss the nature of synchronism here. And we may have combined series and shunt compensators. We have UPFC, Unified Power Flow Converter, or IPFC, Interline Power Flow Converter. In this Unified Power Flow Converter, we have both, that is STATCOM and SSSC, put in the same line. But in this IPFC, we have two different this triple SCs connected in two different lines, but they are coordinated. They are usually coordinated to each other. And we may have voltage and phase angle regulators. Here voltage is usually controlled, here phase angle, that is delta, is controlled. In nutshell, we have this type of or these type of controller that we are going to discuss, or we are going to learn in this chapter or in this subject. So this is the syllabus, detailed syllabus. I have actually the contents are actually taken from this syllabus. This is the detailed syllabus. You can see we have introduction to the fact devices, need of transmission, interconnection, power in AC, that we have that the equation that I have told you in the beginning, that comes from the derivation of this power flow. We have stability consideration, that's very important. You'll see that because if we increase the power transfer capability, we need to consider stability consideration as well, because our power system is dependent upon the stability, this synchronous stability as well. We have to take care of that as well. So different controllers, their importance, definition of the different facts controllers, and benefits from the fact technology. And the second one is the uh, shunt compensation. The objective of shunt compensation: voltage control, SVC, where characters of SVC, SVC applications, prevention of voltage instability, STATCOM, and their comparison. In the third chapter, we have series compensation, operation of TCSC, different modes of operation, modeling of TCSC, variable reactance model, transient stability model, etc. So this is you can say shunt compensation. This is series compensation. Then we may have voltage source converter, that is the and current source converters, that is actually used for these SSSCs or UPFCs and IPFCs. So here we have to use the combined series and shunt controllers. So in the last chapter we may have thyristor control phase angle regulator, that is the change of delta, thyristor control voltage regulator, and thyristor control braking resistor. We'll all discuss them one by one. And finally, industrial application of the fact devices. So this was about the syllabus that we have to cover in this subject. So some recommended books. The first one is the Hingorani, that is usually known as Narayan G. Hingorani and Lazy Vivi. Understanding Facts, Concept and Technology of Flexible AC Transmission System. This is one of the famous book for the facts technology. We have one more, that is RKPDR, Facts, Controllers and Power Transmission and Distribution. This is also used for this recommended book for this subject. One more book that is also very much famous for this facts technology, that is thyristor-based facts controllers for transmission, electrical transmission system. It is the authors are R. Mathur and Rajiv Kumar. In this lecture, I will stop over here. So, as I have told you earlier, that I am going just to briefly introduce you, and uh, I will discuss about the contents and the recommended books. Okay, thank you.